Welcome to Mathematics Lecture Series, Laplace Transform of Derivative Lecture number 8. Laplace Transform of Derivative. If Laplace of f of t f of s, then Laplace of f prime of t is equal to s f of s. This f of Laplace of f of t f of s minus f of 0 function at the point 0. And show that this generalization Laplace of f nth derivative of t Sn f of s means Laplace of f of t minus Sn minus 1 f of 0 minus Sn minus 1 f prime of 0. This will goes to on minus s f n minus 2 derivative at the point 0 minus f of n minus 1th derivative at the point 0. So we have to prove this theorem or this property. You know that by the definition of the Laplace transform, Laplace of f of t is equal to f of s, which is equal to 0 to infinity e power minus st f of t dt. It implies that Laplace of f prime of t, by using this definition, Laplace of f prime means f first derivative of t is equal to 0 to infinity e power minus st f prime of t dt. Here you taking integration by parts. By the integration by parts, you will have e power minus st integration of this f dash of t is equal to f of t 0 to infinity minus 0 to infinity derivative of e power minus st, which becomes minus s e power minus st f prime of t integration is equal to f of t dt. So here apply the upper limit e power minus infinity minus lower limit e power 0 f of 0 minus into minus s 0 to infinity e power minus st f of t dt. So here e power minus infinity is equal to 0, e power 0 is equal to 1 f of 0 plus s 0 to infinity e power minus st f of t dt minus f of 0 as this 0 to infinity e power minus st f of t denoted the Laplace of f of t denoted by f of s. So this is proof of the first derivatives, Laplace of first derivatives, which becomes minus f of 0 plus s f of s. Similarly, you can easily find Laplace of f double dash of t, f double prime of d, f double derivative of t by using integration by parts e power minus st, taking first f of taking integration of double dash t, which becomes f dash of t upper limit lower limit minus 0 to infinity here e power minus st, taking the derivative of s e power minus st and f dash t integration dt. By integration by parts we have this form. So use here upper limit, you will have e power minus infinity, use lower limit e power 0 f prime of 0 plus s minus into minus plus s 0 to infinity e power minus f stf dash of t dt. E power minus infinity, it is becomes 0, minus e power 0 is 1, so minus f dash of 0 minus f dash of 0 and plus s, this becomes Laplace of f dash of t minus f prime of 0 plus s, this Laplace of f prime of t is goes to s f of s minus f of 0, which we have already proved here. Laplace of f prime of t is equal to s f of s minus capital F of 0. Just we have applied the values s f of s minus. So f dash of 0 multiply s with s square f of s minus s f of 0. So Laplace of f n of t is equal to s power n f of s. If we generalize, we have proved till two derivatives. Similarly, by generalization, we can write this formula: Laplace of f of nt s of n f of s minus s n minus 1 f of 0 minus s n minus f prime of 0 s f n minus 2 at the point 0 minus f n minus 1 0. This property is very useful for solving differential equation. So ends the lecture. The channel and share the video. Thank you.